Hello, this is section 3.4, Graph Linear Inequalities. Recall, a linear inequality is an inequality that can be written in the form ax plus by is less than, greater than, less than or equal to, greater than or equal to, or not equal to a number c. In order to pair x1, y1 is a solution of a linear inequality if the inequality is true when x1 and y1 are substituted into the inequality. Determine if each point is a solution to the inequality 3x plus y greater than or equal to 8. First point, 3, negative 2. So we plug 3 in for x, negative 2 in for y, and see if it's greater than or equal to 8. So we get 9 minus 2. Is that greater than or equal to 8? And then we get 7. Is that greater than or equal to 8? No, it is not. The second point, 0, 12. 3 times 0 plus 12. Is that greater than or equal to 8? Well, that would be 0 plus 12. Is that greater than or equal to 8? Which is 12, which is. So that one does work. And the third point, 2, 5. So we get 3 times 2 plus 5. Is that greater than or equal to 8? 6 plus 5, 11. So that one checks out as well. Graphing linear inequalities. The graph of a linear inequality is the collection of all, notice the capital letters there, points that satisfy the inequality. The graph of a linear inequality takes the form of a shaded region with either a dotted line for greater than or less than, or a solid line for less than or equal to, or greater than or equal to as a boundary. So if it's less than or greater than, we're going to get a dashed line and then a shaded region. If it's less than or equal to or greater than or equal to, we're going to get a solid line and then a shaded region. So they're going to look something like these two examples. To sketch the graph of a linear inequality, first find the boundary line by replacing the inequality symbol with an equal sign and graph the resulting line. So this is just like in the previous sections of graphing a line. We will shade the side of the boundary line that contains all points that satisfy the inequality. To determine which side to shade, we begin by choosing a test point. If the test point satisfies the inequality, then shade that side. Else, if the test point does not satisfy the inequality, shade the other side. Now, you may have been taught in high school if the inequality is greater than, shade above. If the inequality is less than, shade below. Unfortunately, that only works in very specific cases, which are usually the only cases they give for homework in high school, which is why that rule works. In general, though, that rule does not work, so you do need to do a test point. X greater than or equal to negative 3. So the first thing we have to do is graph the line. Well, if I change this to x equals negative 3, that's the equation of a vertical line. So I'm going to get a vertical line here. And then it is solid because my inequality had an or equal to part. Now I have to determine which side to shade. So you want to pick a test point. And usually for the test point, I pick 0, 0. Now, because the test point has to be in one of the regions, it cannot be on the line. So for example, I could not pick 0, -3. That point would not work. What that means is if your line goes through 0, 0, you can't use 0, 0. You have to use a different point. But here we can choose 0, 0, plug 0 in for x. Is 0 greater than or equal to -3? That is yes. So then I'm going to shade on that side. 2. 3x plus y is less than 2. So again, I need to find the boundary line, so I'm going to change it to an equal to sign. Solve for y. We get y equals -3x plus 2. Well, this has a y-intercept of 2, a slope of -3, and there's our line. But because there is no equal to part, it has to be dashed. Pick a test point. Again, I'm going to pick 0, 0. That would become 3 times 0 plus 0. Is that less than 2? Always plug it into the original inequality, not this one. So then that's becomes 0 less than 2, which is false. So then I shade on the other side. There we go. 4x minus 3y is greater than 12. Again, I'm going to do 4x minus 3y is equal to 12. And instead of solving for y, this time I am going to do the cover-up method. So when I cover up the y, and solve for x, I get x equals 3. So my x-intercept is 3, 0. And now when I cover up the x and solve for y, I get y is -4. So then my y-intercept is 0, -4. And then I'm going to connect them with a line. And it has to be dashed again. There we go. Pick a test point. 0, 0. 4 times 0 minus 3 times 0. Is that greater than 12? Get 0 minus 0. Is that greater than 12? Is 0 greater than 12? That is false. So I shade on the other side of the line. Okay. And then the last one for this video, we get 2x minus 2y less than or equal to 8 plus 2y. So again, need to do the boundary line. Going to add 2y to both sides. At the same time, I'm going to subtract 8. So we get 2x minus 8 equals 4y. Divide by 4. Divide by 4. We get 1/2 x minus 2 equals y. So we have a y-intercept of -2 and a slope of 1/2. There is an or equal to part, so my line is solid. I can choose 0, 0 again. So 2 times 0 minus 2 times 0 less than or equal to 8 plus 2 times 0. 0 minus 0 less than or equal to 8 plus 0. 0 less than or equal to 8. That is true. So I shade on the same side. And that is how you graph linear inequalities with two variables.